Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. 2019 calculus was question 8. The weekly revenue produced by a company manufacturing air conditioning units is seasonal. The revenue in euro can be approximated by the function R of t is equal to 22,500 cos of pi over 26 times t plus 37,500, where t is the number of weeks. That's important. From the beginning of July, and your angle is in radians. Okay, find the approximate revenue produced 20 weeks after the beginning of July. Okay, so 20 weeks. So T is the number of weeks. So if they're going to ask me a question 20 weeks, then T must be 20. Okay. My angle is in radians. So the first thing I'm going to do is check my calculator is in radian mode. It is. Okay. So therefore, R of 20 is equal to 22,500 cos pi over 26 times 20 plus 37,500. Put all that into the calculator. And of course, you can write him as 20 pi over 26 if you want. That's easier. And just be careful when you're putting it in, because the 37,500 is not part of the angle. So make sure it looks like a double close of a bracket beforehand to the nearest euro. So I got 20,658.5, so 20,659 euros. Okay, so that was part A, and there was actually 10 marks for that. It was nice. Find the two values of the time t within the first 52 weeks when the revenue is approximately 26,250. Find the two values of t. So in other words, we're solving 22,500 cos pi over 26t plus 37,500. We're solving that for t when it's equal to 26,250. Okay, so I'm going to minus the 37,000 from both sides, so that I have 22,500 cos of pi over 26 times t being equal to 26,250 minus 37,500, and I'm getting minus 11,250. Divide both sides by the 22,500. So what am I doing all the time? I'm stripping away from the left-hand side until I get at this t. Okay, so this was the furthest away, so he came over. I'm then dividing by this. So all the time I'm getting closer, in and in and in, in and in and in, till I get at the cos pi of 26 times t. Okay, so he cancels. So that I get, I'm just going to come up the top now because I know I'm going to need more space, cos of pi over 26t being equal to, divide those two, minus a half. Okay, so find the two values, I presume. Yeah, the two values of the time t. Okay, so you have cos of an angle equal to a half. So this is where trig meets calculus or functions. So let's draw cast. Okay, my angle is negative. So where in cast is your angle negative, or where is cos negative? Well, what does cast mean? It tells you what's positive. So in quadrant 4, which we call this one, cos is positive. In quadrant 1, all sine, cos, and tan is positive. In quadrant 2, sine is positive. In quadrant 3, tan is positive. And I'll have much more of this in the trig videos. But our question here is, where is cos negative? So cos is negative here and here. So in quadrant 2 and in quadrant 3, all is positive here, cos is positive here. Okay, so my reference angle is where is yeah. Let me just get the cos inverse of both sides first. When I'm doing these questions, I don't use the sign as part of my angle. I just use the sign for location within the cast, which quadrant. So to solve this, the opposite of cos is cos inverse. So I'm going to get the cos inverse of both sides. Okay, so that I end up here getting pi over 26t being equal to the cos inverse of a half. So I deliberately dropped the minus there. Okay. So when I do that, I get pi over 26t being equal to a third pi. Just double checking my answer there now. Yeah, a third pi. Okay, now this here is what I call my reference angle. Okay, not so much my solutions, because I have made no reference yet to the minus that was there, or no reference yet to quadrant 2 and quadrant 3. So in quadrant 2, okay, what we do is, if I label this up, this is naught, this is pi over 2, and this is 3 pi over 2, and of course it's 2 pi again. Okay, maybe I'll draw a bigger cast down here for you, and I can wipe it off after, but okay. So if you know cast, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Okay, so that's it in degrees. The equivalent in pi's or in radians, well, is 180 degrees is pi, 360 degrees is 2 pi. Okay, halfway between 0 and pi is pi over 2. Halfway between pi and 2 pi is 1.5 pi's, or 3 pi over 2. Okay, so when we have a reference angle and we're talking about quadrant 2, which is here, that's where our third pi is. Okay, to find out an angle within quadrant 2, it is it's pi minus your reference angle. Okay, down here in quadrant 3, it's pi plus your reference angle. Okay, now why is that? Well, to get to quadrant 3, right, you always start from here. This is your start line. So any angle you're talking about, you're starting here. So to get to the third quadrant, can you see I have to travel at least 180 degrees or pi, and then my reference angle further. So that's why it's pi plus your reference angle. When I'm in quadrant 2, I again start here and I travel up until a distance of 180 or pi minus your reference angle. Okay, so that's what I'm doing up here when I'm working out my actual angles for this question. Okay, so in Q2, it is pi minus my reference angle, which is equal to, I think of pi as 3 over 3 pi, so 3/3 pi, so 2 over 3 pi. And quadrant 3, I add it on. And remember, I can write a pi as a fraction. It's 3 over 3 pi, so there's 4 thirds pi. Of course, you could do that in the calculator, but I'm just doing it in my head. Okay, so what does that mean? Well, that means I can continue my question here. Pi over 26t is equal to 2/3 pi. So it's no longer just a reference angle, it's the actual angles, okay? And pi over 26t is equal to 4/3 pi. Okay, and then I solve for t. So just like any other question, you divide by the number in front of t. I divide by the number in front of t. So that I get t equals, so into my calculator, I have 2/3 pi. So the way I get around complicated fractions like this is that I would put in the divided by symbol for that rather than another fraction. And then I'll hit the fraction button and just go pi over 26 for that one. And I am getting 52/3. And for the other one, just hitting back on my calculator instead of 2/3, it's 4/3. I'm getting 104/3. So there's the two values of time within the first 52 weeks that the revenue is 26,250. Okay, and when you know more about trig functions, you'll be able to draw that and you'll see that these actually do make sense. Okay, the last part then, find r dash t, the derivative of r of t, equal to 22,500 cos pi over 6t, and so on and so forth. Okay, so let's try that one. So the derivative, so r dash t is equal to, well, that's going to go. So it will be 22,500 by sine goes to cos. No, cos, sorry. Did it the wrong way. Cos goes to minus sine of the angle. Okay. By, remember, this is, can the inner function be in itself differentiated? Yes, it can, which makes this is a chain function. So if you differentiate what I put in that box, you'll get pi over 26. Okay, now let's see if we can tidy this up. So I get 22,500 pi over 26. Let's put the minus at the front. Sine pi over 26t. And then into my calculator, I'm putting 22,500 over 26 to see what that divides down to. And it divides down a little bit, not as much as I like. Over 13 sine of pi over 26 times t. Oh, I forgot my pi there. Okay, and then there's nothing more I can do with that one. So that's r dash t. Use calculus to show that the revenue is increasing 30 weeks after the beginning of July. So if the revenue is increasing, that means it has a positive slope. Okay, that is the link between dy dx, because slope is dy dx. So if you've got a positive slope, if you think about it, if this is your function, if you have a positive slope, then don't you have an increasing function? If that function was decreasing, then wouldn't you have a negative slope? Okay, so we use dy dx to figure out the slope at a point. If it's a positive slope, and again, the value doesn't overly matter. It just shows you how, I suppose, the rate of change of the curve. But if it's positive, then it was an increasing function. So what I'd like to do then is to write down my function, which was r of t is equal to minus 11,250 pi over 13 sine of the angle pi over 26 times t. Okay, so 30 weeks. Didn't it tell me my t was the number of weeks? So r dash of 30 is minus 11250 pi over 13 sine of 30 pi over 26. Okay, let's put that into the calculator, see how we get on. So minus 11,250 pi over 13, and I need to multiply that by the sine of 30 pi over 26. And I got 1263.44 for that. And then slope is positive, therefore increasing function. Okay, don't forget your line that shows complete understanding. Very, very important. Find a value for the time t within the first 52 weeks where the revenue is at a minimum. Okay, so at min max, dy dx is equal to 0. Okay, so I take that function, so minus 11250 pi over 13, the sine of pi over 26t, and I let it equal to 0. Okay, because that's how I find a max min point. Okay, let's bring this over the other side. And you can see that that's then that multiplied by 0 means it's going to be 0. Okay, let's get the sine inverse of both sides. And we're getting pi over 26t being equal to 0. And this is a special case. So if you get the sine inverse, let me just check before I do it. If you get yeah, sorry, I'm jumping ahead. Okay. To the sine inverse of 0. Okay, so pi over 26t, when is a sine function 0? Well, it crosses at 0 or at pi. Okay, again, we'll do more of that in trig. So therefore, we will get it when t is 0, and let's take pi and divide it by pi over 26. I should have known it was 26 because it's halfway over. Find a value for the time t when revenue is at a minimum. Okay, so I have found 2 when revenue is at a minimum. Well, I have found 2 turning points, let's put it that way. They could, of course, be min, max, or points of inflection, because dy dx equal to 0 gives me all turning points. Okay, so to find the nature of turning points, we use d2y dx squared. Okay, so let's differentiate r dash t again, and I will get minus 11250 over 13 pi. Okay, so the constant stays the same. Sine goes to cos. of pi over 26t, and of course I must multiply it by the inner function differentiated. Okay, so let's tidy up. Well, actually we don't even need to, because let's test. Let's test our answer when t is 0 and see what we get. Okay, so I will get minus 11250 pi over 13 times pi over 26 times cos of course 0. Okay, let's put that into the calculator. Minus 11250 pi over 13, and that has to be multiplied by, hit the fraction button, pi over 26, and then cos 0 is 1. So I'm getting minus 328 for that. It's less than 0, so it's a max turning point. Okay, so then by default then you think the 26 is going to be a min. And the theory is, if the 26 is a min, then my value here is going to be greater than 0. Okay, so let me try that one. So in an exam, I wouldn't rub this out. I'm going to rub it off here now, just so that I have space to test the 26. Okay, but it is in the recording, so feel free to check it. So I'll have minus 11250 pi over 13 times pi over 26 times cos of 26 pi over 26, which is cos of pi. Okay, so it's in my calculator already. I just need to put in, instead of cos 0, put in cos of pi, because the 26 and the 26 are going to cancel. And for this one, I get 328, which is greater than 0, therefore a min. Okay, so t is equal to 26 when revenue is minimum. Okay, and we used d2y dx squared to find the nature of the turning points. And that's where d2y dx squared comes out of its own. You test each of the values that you got as a turning point, and you determine what is their nature. Is it a min? Is it a max? And of course, if we got equal to 0 here, then that's what we call a point of inflection. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.